All right, in this video, we're going to be talking about different types of shapes that fall under the umbrella of a parallelogram. So I just want to start with kind of talking about the properties of those. You've probably heard of all these shapes. So all the properties of parallelograms are going to apply to these shapes, but the shapes that you see below here, rhombus, rectangle, and square, have additional properties that can help make things solve for it a little bit easier. So we'll start with probably one of the most basic shapes we know, a rectangle. We know area of a rectangle is length times width. The basic definition of a rectangle is a quadrilateral, a four-sided figure that has four right angles. If I tell you that alone without any other information, it's going to form a rectangle and nothing more, nothing less. It ends up being a parallelogram. It has all the properties that a parallelogram has, but it has, in addition to four right angles, something about its diagonals being the same measure. So its diagonals are going to be congruent to each other. So if I were to connect the opposite corners and measure them, this length and that length are equal to each other. Those two are also equal to each other because they bisect each other, but all four of them have the same measure. So that's equal to that, equal to that, equal to that. So that's what kind of makes the diagonals a little bit more unique in a rectangle. In a rhombus, if you don't know what a rhombus is, a lot of people call it a diamond. A rhombus is a four-sided figure where all four sides are congruent. So if I were to mark that, it would be something like that equals that equals that equals that. Now in a rhombus, the angles aren't necessarily going to be right angles, and they're not going to make a square, but what we do know is that the four sides are congruent. The diagonals are going to be perpendicular. Perpendicular means they cross at 90 degrees. So if I were to make two diagonals, they would form a right angle in the middle. And then finally, the diagonals bisect. They bisect each other, but they don't necessarily equal each other like a rectangle, but they do bisect opposite angles. What that means is if I were to look at this opposite angle here, those two angle measures are going to be the same measure. And then those two are going to be the same measure. So you're going to have this little relationship where these four are equal to each other, and over here, those four. So you're going to have four right triangles as a result. Makes things solving for a little bit easier in the inside of a rhombus. And one thing you'll know about the area of a rhombus is it's going to be 1/2 the two diagonals being multiplied together. So if you times the diagonals together, diagonal 1, we'll call that D1, and we'll call this D2. Find those lengths, multiply them together, and divide by 2, you'll get the whole area of the rhombus. Finally, a square. Well, y'all know what a square is. It's the most basic of all shapes. Four right angles, four equal sides. It is a regular quadrilateral. And the only thing that I can add to that, this has all the properties that everything above it has. The area of a square is going to be length times width, but since the length and the width are both the same, we call that side. We'll just say side times side, which is side squared. It's got all the properties of a rectangle, a rhombus, and a parallelogram. So the nice thing about a square is diagonals are congruent to each other. They bisect each other. And all these angles here as a result are going to end up being 45 degrees because they're just half a 90, right? Everything gets cut in half. So it makes things solving for pretty easy. We're going to end up using something called, Pythagorean theorem to help solve for some of these sides in the triangles. Whoa. Those are all going to be 45. You get the idea. I'm not going to sit here and draw all these 45s. Well, maybe I will. Then, of course, in the middle, they will form a right angle. So there's going to be a right angle in the middle as well. So let's get started on a few examples. All right, so in this problem here, we're dealing with a rectangle here, and we want to be able to find the length of AC. AC is a diagonal. So I want to know, what is that length here? I'm going to go ahead and highlight that so we can see what we're talking about. It's always good to draw a picture, even if you don't have one. So notice it's rectangle ABCD. I draw it like this. Here's what I do have. I know that AC is 4x minus 12. And I know DB is the other diagonal. And those two diagonals are the same length. So I know that the measure of angle AC and DB are going to be equal to each other since diagonals are congruent. Diagonals are congruent, those are equal to each other. So what I can do is I can substitute those expressions in. 4x minus 12 equals 2x plus 8. And once again, we're going to have an equation to solve. So we're going to get all the x's on one side. I will subtract the 2x from the 4x. That's going to give me 2x minus 12 equals 8. Those cancel out. Next thing I want to do is I want to add that 12 to both sides. 8 plus 12 is going to be 20. And then finally, divide by 2. So x is going to be 10. Now the question is not asked for x, the question is asked for AC. So AC is the length represented by 4x minus 12. So when I'm saying what is the length of AC, I want to know what is the value of a 4x minus 12 when I substitute in that 10 here. So I'm going to plug that 10 right in there, evaluate it, and that'll be my length. 4 times 10, 40 minus 12. 40 minus 12 is going to be 28. And I could go through and I could get all the other individual measures if I wanted to. I know AC is going to be 28, which means DB would also be 28 too. So I could actually split these in half, and those would be 14, 14, 14, 14 if I wanted to go a little bit more in depth with it, because those are all equal to each other. But 28 is my answer for this question. In this example, we're dealing with a rhombus. So we have a rhombus drawn here. This is going to be rhombus EFGH, and what we know about this rhombus is the diagonals. So EG is going to be 12, and HF is 16, and it's really bothering me that those are different lengths here, and these should be drawn to scale, but they're not. So EG is 12, so I'm going to go ahead and mark that. And I know HF is 16, so HF, these are different lengths. And one thing about a rhombus is they do make right angles in there. And I'm asked for the perimeter of EFGH. Perimeter is distance around. Perimeter is how do all four sides combine to give you an answer to this question? Well, one thing about all four sides in this problem is they are all congruent. In a rhombus, EF, FG, HG, EH, they're all the same length. So when I find one side, I found them all, and I can just say add them up or do 4 times that number and I get my answer. So what I'm going to do here is, well, what I do know is that my rhombus has diagonals that bisect each other. Because it is a parallelogram, diagonals bisect each other. So what can I do with that? Well, I know this is 12. That means these two lengths will be half of 12. So what you're going to do is you're going to take that 12 and divide by 2. And that'll give me a little 6 there and a 6 there. Now I can go to that 16. I'm going to make those red. Now I can go to that 16, and I can take that 16 and divide by 2 to get these two. So that's going to be 8, which means that's going to be 8, and that's going to be 8. So diagonals bisect each other allows me to cut that in half. Why do that? Well, from there, what we're going to do is we're going to make ourselves a right triangle. Another property of rhombuses is that the diagonals are perpendicular. Perpendicular has a symbol, Looks like an upside down capital T, but it means that they cross at 90 degrees, which means I can make a right angle there. And so now I'm going to take that, one of those triangles there, pull that out for a second. Do you see a way that I can take that 8, 6 and figure out what is the side length of that rhombus? Well, I have a right triangle. I have two of the sides. I'm trying to find, this is the hypotenuse. Remember, the hypotenuse is the longest side. The hypotenuse is the longest side in any right triangle. And I have a formula to get that. Do you remember what that formula is? It's the Pythagorean theorem, a squared plus b squared equals c squared. I know you've learned that before, but I wanted to write that on there just in case you need to. So I'm going to call the side C, and I'm going to plug in that 8 and 6. Doesn't really matter the order you put those in. You're adding them together anyway. So how do we solve for that? Well, we square the 8 and the 6. That's going to give me 64 and 36. Add those together. Yep, that's going to be a 100. And then finally, I want to solve for C. How do I undo C squared? Square root takes the inverse operation of a square. So square root cancels that out, and the square root of 100 is going to be 10. 10 is C. 10 is your side. So how do I get the perimeter? Add up all the sides. Add all sides. How many sides do we have? 4. What's true about them? They're all equal to each other. 10, 10, 10, 10, 10 plus 10 plus 10 plus 10. Or I could do 10 times 4. Probably a quicker way to do that, 10 times 4. And my perimeter is going to be 40 units. So 40 is the answer to this question. The perimeter is the distance around the whole figure. In this case, they're all equal lengths on the sides. In this last problems, we actually have two problems dealing with a square, so it's split up into two different slides. We have first the perimeter of a square is 60 inches. What is its area? It's always a good idea to draw that out. So we'll draw ourselves a square, best square we can draw freehand. It's not about how good it looks, it's about how well you know how to do the problems and the math behind it all. So don't judge me too much. All four sides are equal, all angles are 90 degrees. I know the perimeter is 60. What does that allow me to do? Well, if all four sides are equal, then one side should be 1/4 of the perimeter. So I can take that 60 and divide by 4. 6 divided by 4 is 15. Since my units are in inches, each side is going to be 15 inches. It's kind of redundant to draw all those on there, but that's okay. And I want to know what's the area. Well, how do I get the area of any rectangle? Well, it's the same as a square. It's length times width. But we don't say length and width in a square because the length and width are both the same. We say side, side. So the area of a square is side times side. Side times side is side squared. So when you see this little s squared, that just means length times width, side times side. 15 squared. Why do you think it's called squared, guys? Squared. Because you're talking about the sides of the square. 15 times 15, what do you get? 225. What's my unit? Inches. No, inches squared. Area is square units. So my area is 225 square inches or inches squared. That's how you represent that. Last square example. Then you can go and try your problems. We have once again, a square not drawn for us. We're going to draw it out for us. Oh, look at, I can make a shape. So I have a diagonal of a square is 18 inches. Well, that's a lot prettier than what I can draw. Let's see if I can make that a square. Close enough. So the diagonal of a square is 18 inches. 18 inches. So let's see, 18 inches. Not too bad, 18 inches. What's the perimeter? Well, back to that perimeter again. Perimeter is 4 times the side, so I know that all the sides are equal, but that's about all I got. So there's a couple approaches to this problem. First thing you should know is that's a right angle, and I know that the sides are all equal. So what if I call the side x? I could call all the sides x, and then my perimeter would just be 4x. That doesn't help me actually get it because I don't know what x is yet. But what I can do is I can make myself another right triangle. And I can solve using, once again, Pythagorean theorem. The only difference here is this time I have the longest side. I have the hypotenuse. I don't have the two legs, but the two legs are equal. So I still can solve for those using a squared plus b squared equals c squared. But what I have to understand is a squared and b squared are both going to be my x value, okay? A, b are the same length. Here's my c. So when I'm setting that up, I'm going to say x squared plus x squared equals 18 squared. Now I have one variable I can solve for it. Now how do I combine those? Well, that's x squared plus x squared. Those are like terms. They have the same exponent for your variable. So how many do I have? I have 1x squared, 1x squared. I have 2x squared. 2x squared. 18 squared. Well, 18 times 18 is, using my calculator, 324. Now I can solve that pretty easily. What I'll do is I'll divide both sides by 2. 324 divided by 2 is 162. So x squared is equal to 162. And once again, if I want to solve for x and I have it squared, I'm going to do the square root. Both sides, that cancels out the square. And my value of x is going to be a decimal in this case. 162, the square root of that is about 12.7279. How do I round? Well, it doesn't say to, what to round to. So my recommendation would be to go out at least 2 spots, maybe 12.73, but let's just be on the safe side and go out all 4. And it's going to keep going forever, so you can go as far as you want. But I'm going to use those 4. Now, the perimeter is going to be 4 times the sides. So the perimeter is just going to be 4 times, and I'm going to substitute this number in right there, 12.7279. And on my calculator, it's easy. I can just say times 4, and that's going to give me about 50.91. What's my unit? Well, these are inches. Perimeter is a length, so we do not do square inches, we do inches. By the way, that's inches. 50.91 inches, or about 50.9 inches if you want to be a little bit more rounding. Guys, I hope these problems were helpful for you, and you should be able to go do all your assignment problems that are required for you in your class. And if you have any questions, ask your teacher. Thank you. Bye.